For this example, for the properties of air, the question states that a 5 meter times 5 meter times 3 meter room shown in the figure below contains air at 25 degrees Celsius and 100 kilopascal at a relative humidity of 75%. Determine the partial pressure of dry air, the specific humidity, the enthalpy per unit mass of the dry air, and the masses of the dry air and water vapor in the room. Given to us is the value for total pressure, temperature, and relative humidity. We know that relative humidity is equal to PV over PG, and the value for the relative humidity will be equal to 0.75. Since given in the question is in the form of percentage, therefore we need to divide this value with 100. And we can find the value of PG, since we know that PG is equal to saturation pressure at desired temperature, which is in our case is equal to 25 degrees Celsius. Now we can obtain the value for PV. After we have determined the value for PV from the equation of total pressure, we can determine the value for partial pressure of dry air by subtracting the total pressure as given 100 kilopascal with the value that we have calculated, PV. Next, we know that specific humidity omega is equal to 0.622 times PV divided with P minus PV. Since we already have the values for PV and also P, therefore we can solve this specific humidity. Now, for the enthalpy, we can determine by using this equation. Since we already have the values for CPA, T, omega, and also CPV, then we can determine the value for enthalpy per unit mass of the dry air. Lastly, for the masses of the dry air and water vapor in the room, it can be determined by using the ideal gas equation of state for each dry air and water vapor. In this analysis, we already determined the value for partial pressure of the dry air and also partial pressure for the water vapor. The volume can be determined from the information given, while for the values of specific gas constant for the dry air and also the water vapor, we can retrieve the values from table A2, which the dry air will be using air, and for the water vapor we'll be using steam. For the temperature, we're going to use 25 degrees Celsius, but please bear in mind for ideal gas equation of state PV equal to MRT, the temperature should be in the unit of Kelvin. So you need to convert this 25 degrees Celsius into unit Kelvin. Now we can find the value for the mass for the dry air and water vapor.